Hello students, the topic is John Taylor Distortion. This is a very important topic of inorganic chemistry that we study in the MSc first or second semester. John Taylor Distortion we study with respect to transition elements. Transition elements, or the otherwise called the D block elements. They are called transition elements because they transit the property from S block electropositive elements to group 17 of P block, which contains electronegative elements. The topic is John Taylor Distortion, an important phenomenon which is shown by the transition elements. The transition metals have the general electronic configuration Ns 1 to 2, N-1, D 1 to 10. This is a peculiar property shown by the transition elements. What is this John Taylor distortion? It is the distortion in the overall shape or geometry of transition metal complexes, which occurs because of the presence of electron in the symmetrically orbitals. These symmetric orbitals I will explain with respect to two configurations. They are D1 and D3. When we consider the D1 configuration of octahedral field, the electron is present in the first orbit, or it may be present in the second orbit, or it may be present in the third orbit. That is, the electron is free to move in either of these three orbitals. Whereas in case of D3 configuration, the electron occupy all the orbitals and there are no chances of the electron occupying any other orbital, because all these three orbitals, which are named as dxy, dyz and dxz, they are all degenerate. Degenerate means they all have same energy. So the electron is having equal probability of occupying any of these degenerate orbitals. Whereas in case of D3 configuration, the electrons occupy the degenerate orbital, but there is no other chance of electron occupying any other orbital. This John Taylor distortion causes distortion in the shape and geometry of generally the octahedral complexes, and this John Taylor distortion that I represent as JTD is basically of two types. First one is the Z out JTD and the second one is Z in JTD. The Z out JTD causes distortion, which is leading to the elongation in the bond length of a molecule, and the Z in type of John Taylor distortion leads to the so-called compression of the molecule. And in octahedral complexes, the geometry generally changes from octahedral to tetragonal. In case of Z out type of transition, Z out type of transition leads to elongation because the dz square and dx square minus y square orbitals are present along the axis, and in a complex, when the ligands donate the electron, they donate the electron along the axis. So the electrons from the ligand and the electrons from the transition metal suffers repulsion, and because of this repulsion there occurs difference in the energy levels of the orbital, leading to the elongation. If I am talking of the Z in type of John Taylor distortion, it leads to compression of the molecule. Z out or Z in type of John Taylor distortion causes distortion in the overall geometry or symmetry of a molecule. I will consider the John Taylor distortion with respect to a complex. Let the complex be CuSO4 dot 5H2O. In CuSO4 5H2O, the copper, you know that the outer electronic configuration is 4s1 3d10, and in case of CuSO4, the electrons occupy only the 3d9 orbital. So the electron in the d9 are present like this: 1 2 3 4 5 6 7 8 9. And in case of John Taylor distortion, in octahedral field, the occupancy of electron occurs like this: 1 2 3 4 5 6 7 8 and 9. It is this ninth electron which can occupy either the dz square or dx square minus y square orbital. If the electron, the ninth electron, is present in the dz square, it leads to Z out type of distortion, and if the electron is present in dx square minus y square, it leads to Z in type of distortion. So the John Taylor distortion in copper sulfate pentahydrate is seen because of availability or transition of electron in either the dz square or dx square minus y square orbitals. Thank you.